17th. Guys, say we're talking about rules for exponents. What happens when you multiply what happens when you multiply two bases, two like bases? What do you do to the powers? Anna? Yeah. Yeah, you add them. So over here, x to the 7th times x to the 7th times x squared is just going to be x to the, yeah. Ah, it's a great question. If they're different variables, you can't do anything with them. Yeah. You want me to give you an example, Jamie? Okay. Here's an example. Let's do a random example. Suppose we have a to the 7th times b squared. Do you know what that is? Yeah, a7b squared. You don't do anything. Just stays like that. Okay. Let's skip around a little bit. What happened, man? Let's do number 3. Okay. What happens when you have x to the 9th? Let's use the symbols divided by x to the 4th. Absolutely, you subtract them. So this is going to be x to the 9 minus 4. It's x to the 5th. Let's remember also that this can be written in a particular way. X to the 9th over x to the 4th, it's the same thing. So if one way confuses you, you are more than welcome to rewrite it in another way that you like. Let's step it up. Let's go number 5. Now, people always make fun of me for this. What do you do with that? Yeah, you multiply the exponents. I always say make it rain, because look. You know what I'm saying? It's raining inside. You'll hear me use that kind of vocabulary a lot. That's because typically all things outside of the parentheses multiply the things inside the parentheses, and you should get used to that. So this is going to be a to the 3 times 2, and that's a to the 6th. Piece of cake, right? Let's find some other ones. I am thinking things like, sure, number 7, 2 to the 5th times 2 squared. Oh boy. To the 7th? Let's think about this for a minute. Think about this for a minute before we write down the answer. There are essentially 5 2s. 1, 2, 3, 4, 5. And then there's 2 more. So what do we have? 4, 5, 6. We really have 7 2s. Do you see it? Now what happens, you know what the most common mistake is? You guys already said it. What did you say the other version of it was? Yeah, 4. If you said it was 4 to the 7th, think about what that means in terms of like a math language. It means that there are 7 4s. So you see? Be careful. Don't just write it down and follow a rule. Think about what it's doing. Now we got lots of operations going on. Lots of operations. Where do you start? Terrell, is that what you're going to say? Yeah. John, yeah? Let's do the top first. What do you get when you simplify the top? Yeah, x to the 10th. Very nice. So now we got x to the 10th divided by x to the 7th. What is that? Yeah, all you do is subtract. So that's x to the, whoops. I was thinking too fast for myself. It's x to the third. That's it. How about something else? 24? Let's do, if you could pick an odd numbered one. How about something like 23? Is that cool? And this is the difference between this class and normal algebra. Suppose you have x to the b times just x. Now, x is the same thing as x to the first. Think about the rule. Think about the rule. Not so much the fact that there's complicated stuff there. What's the rule? What do? Ooh, x to the b plus 1. You just add those powers. That's it. All right, let's try 27, right? What happens when you have two things that have the same kind of base? What do you do to their powers? Yeah, you subtract them. Don't get all mixed up with how complicated the problem was. Think about the very basic rules we learned. This is going to be 4c minus c. How much is 4 c's minus 1 more c? That's it. That's all there is to it. 3c. We're done. Let's take a look at 37. You've got 3 to the 4th times 2 to the 4th. I mean, can you combine them? Can you add them? The only blessing that you have here is what? Well, there's no variables. These are actually numbers that you could enter into your calculator. So some of you guys have calculators, others don't. Let's just enter it in real quickly, and then I'll let you get them. 3 to the 4th, it enters 81. 2 to the 4th, 16, and then 81 times 16 is 1296. Whoa. Oh, where's the little caret symbol? Do you see where the clear button is? See, yeah. Let's skip on ahead. Write each as a power of 10, so this will be important. How could you write 100 as a power of 10? Very nice. Yeah, 100 is 10 squared. How about something like 51? That's a million. Power of 10, Jamie. 10 to the 10 to the 6th. Yeah, that's all there is to it. 10 to the 6th. Very, very easy. It just takes a little bit of practice and you figuring things out, but I think that's something that you could get. Let's now do something like, what's up? Let's talk about 52. Sure. You could, but it's asking you to express this as a power of 10. So suppose you have 10 to the 5th times 100 squared, right? 10 to the 5th times 100 squared. I mean, the easiest approach is to do this. Oh, I don't know. That's going to, where'd you get 25 from? What? Dude, 10 to the 20th is huge. Okay, give me some approaches. Give me one person that thinks they solved it, how they did it. Steve? What? Oh, I see what you're saying. So Steve did it like this. Do you see this business right here? 100 is really 10 squared, right? And then you have the squared on the outside. So 100 squared, this is really just 10 to the 4th. You see it? No? James? You can, but before we take some alternative approaches, do you see what Steve did? Yeah. And so the final answer is just 10 to the 9th. Now, another approach that you could have done, but I don't know if your calculator will let you do it, is you could have tried to enter this into the calculator and then rewritten it. Like suppose you did 10 raised to the 5th times 100 squared. Okay, and then you do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 9th. You could have done it that way. But just this simple problem right here pushes the edge of where the calculator can go, because once you break past 9 digits, it starts to do weird stuff. Jamie? 10 to the 4th? Yeah. What's wrong with that? Yeah, you're good. The single easiest thing ever that people always mess up. We're on the back of the page, page 2. Does anybody know the rule for raising stuff to the 0 power? What's up? Absolutely. Anything to the 0 power is just 1. And they try and do some crazy nonsense. Like, for instance, take a look at, oh, I don't know, 7. You will see some ridiculousness in parentheses. This is an easy version of it. 5y to the 0. And people get all caught up because people are like, I don't know how much y is. I don't know what to do. Yeah. The whole thing is raised to the 0 power. So the answer is just 1.
So every time it's a 0, the answer is just 1.
The answer is just 1. But let me give you like how they might mess with you. Suppose the 5 is on the outside of the parentheses and just the y is raised to the 0. How much is that? 5. Good, you got it. Yeah, it's just going to be 5 times 1, which is 5. Excellent. Great. What's that? Never mind. Okay. Let's scroll down. Now let's do negative exponents, the worst of it all. I'm not sure why, but people seem to bug out with them. We're doing 17. How do you write that as a negative? How do you write that as a positive power? Jeff, you know the problem being is that we don't have any we don't have any numbers that we could just plug in or be decimals. But I agree with you. They do come out to be decimals, which signifies they can be what? Yeah. They get written as fractions. So here's what this symbol over here, that negative symbol, in all of math just means direction. For example, if you have a negative number, here's 0, here's -2, here's 2, right? The negative in front just means it's going the opposite direction. Now, when you have exponents, right, suppose you have 2 to the 5th. Which way is it going? It's increasing. It's increasing extremely rapidly. What grows exponentially? That's absolutely disgusting. Do you know? Mold, bacteria. Ugh. If you are a business type person and you are looking for investments and you find something that grows exponentially, sell your house, sell everything you have, put all your money into it. You will be filthy rich in a very short period of time. Okay? 2 to the 5th. So if 2 to the 5th grows exponentially, right, what does 2 to the -5th have to do? It has to shrink really, really, really fast. Really fast. If your investment is doing this, get out. Sell. Oh my God, sell. Like your life depended upon it, because it probably will. Okay? So now, this is shrinking really, 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 really fast. Here's how you would represent that in terms of a positive power. All you do is flip it and write its reciprocal. Yep. Yep. If you want to think of it, here's what the original looks like. Because everything can always be itself over 1. And so the positive version of it is just 1 over itself. So just switch its position. Anything that has a negative exponent in the numerator goes into the denominator. You guys good? Okay. 9r to the negative second. All right. What are we going to do? Sure. Yeah, 1 over 9r squared. Now, in most cases, you'd be fine like that. What happens when you square 9r? What do you get? R. Very nice. So in the end, just watch out for stuff like this on your Regents exam, and even on a test. That's the answer. What's that? Yeah, you don't know what R is. So Carly, like if I were to write it out, when in doubt, write it out. Right? There's 2 of them because that's what that little squared symbol means. So it's 1 over 81 r squared. Yeah. All right. Let's pick another one. Something I know comes up, and this is really what shows up on your test. Let's do stuff like 29. 3 over x to the negative 1. Now something's in the denominator, right? Think about what happens. When it's up in the numerator and what's up? Sorry about that. Sorry about that. So think about it. When something's up in the numerator, like over here, you make it a positive exponent by switching it to the denominator. Now it's in the denominator, so what do you have to do? Who else was going to say? Do you second that? Yeah, that's all you're going to do is switch the bottom into the top. Anything in the bottom that's raised to a negative exponent. So the 3 stays on top, and this thing over here comes upwards, and it just is x to the first. All you're doing is rewriting it with positive exponents. What's that? Sure. 3x is the same thing. Let's practice that again, because that often messes with people. Let's do something like, how about 34? Anna. You're amazing, girl. Great job. 5y to the 10th. We're good? Okay. We got to make one up. We got to make one up. Suppose you have 5/6 to the negative 1. How would you express that one as positive exponents? Carly? Nope. Jamel? Absolutely. That's the right answer. Yeah, that's all you got to do. Do you want me to show you the long way of thinking about it, or do you want me to just show you the answer? The long way of thinking about it is this. Each one of these guys right over here has a 1 in front of it. You know what I'm saying? What happens when you have a number on the outside of the parentheses? We talked about that at the beginning of today. Yeah, make it rain, right? Make it rain. It's got to multiply everything in that parentheses. So you suddenly get 5 to the negative 1, 6 to the negative 1. Then, if things are raised to negative powers, how do you make them positive? You just change their relative positions. So this is just 6 over 5.